So in this lesson, we're going to take a look at quartiles and percentiles and a couple of other things associated, again, with data analysis here. The first additional one that we're going to look at is what is called the range. So we're going to want to be able to determine the range for a set of data. And for quartiles, we want to be able to determine the quartile boundaries and the interquartile range for both raw data and group data. And as we do this, we'll take a look at what quartiles actually tell us about the data that we have collected. And an extension of quartiles are what are called percentiles. So again, for a given data value, we want to determine what percentile it falls in for both raw data and for group data. So what are we talking about here? What's the big idea? Well, in the last lesson, we talked about mean, median, and mode. And we said that those were all measures of central tendency, where the middle of the data is. Now we're going to take a look at what are called measures of spread. And these are ways of measuring how far the data lies, or how far an individual data value tends to lie from that middle value. i.e., we're looking at how spread out your data is. And we don't want to just say it's pretty spread out or very close together. We want to attach a numerical value to measure this, this spread. So the first one we're going to take a look at is what is called the range. Okay? The range is just the difference between the largest and the smallest value. So again, just taking the largest minus the smallest gives you a sense of how spread out it is. It's very easy to calculate, but it's very, very sensitive to outliers. So usually it's not used frequently in any kind of statistical calculation. Values that give you a little bit more detail and a little bit more robust are what are called quartiles. So last lesson we talked about the median, and we said that the median was the middle value when the data are written from smallest to largest, or that it divides the data into two groups with the same number of values in each one. Quartiles do something very, very similar, except they divide the data into 4 equally sized groups, again with the same number of values in each one. So the boundaries between these quartiles are called Q1, which is the boundary between the first quartile and the second quartile. So on our little picture here, you can see we've divided this into the bottom quartile, lower middle, upper middle, and then the top. Q1 would be this boundary between the bottom and the lower middle quartile, between the first and the second. Essentially, Q1 is the median of the lower half of your data set. The division between the second percentile and the third percentile is Q2. And Q2 is just your median. It's what divides your data set in half. And then Q3 divides the top half of your data set into, it's the median of the top half of the data set. So it divides it into the third and the fourth quartile. The interquartile range gives you an idea of how spread out your quartiles are. It's defined as the difference between your Q3 value and your Q1 value. And your interquartile range contains 50% of your data. So basically it contains the middle half of your data set. So what you're measuring with the interquartile range is how wide a range do you need to get half of your data in it. And so it's less affected by outliers that are far away from your median value. So your interquartile range, often called the IQR, okay, has got the middle 50% of the data in it. So let's take a look at how you would do this for a set of raw data. Okay. A random survey of people at a science fiction convention were asked, asked them how many times they had seen Star Wars. Some bad grammar there, but I think you get the idea. The results are shown below. So they asked a bunch of people. These are the answers that they got: 3, 4, 2, 8, etc., 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 etc. From this, we want to determine the range, the quartile boundaries, Q1, Q2, and Q3, and the interquartile range. So the first thing we are going to do is we are going to take these numbers and we are going to write them in order from smallest to largest. Because if we're finding our quartile boundaries, it's kind of like finding our median. So let's write these in order. So our smallest one is clearly, well, let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have 20 values here. Our smallest one is 1. We've got a 2. We've got a 3. We've got another 3. We've got, oh, I missed a 2, so we've got to go back. Another 2. And then another 3. So that's 1, 2, 3 threes. We've got a 4. We've got another 4. We've got a 5. We've got another 5. We've got a 6. We've got a 7. An 8. A 9. A 10. Another 10. And then a 12. A 15. A 16. And a 30. That's a lot of times. So let's just double check here, make sure that we've got 20 numbers in our set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so 20 again. Well, once we've got them in order, the range is pretty easy to calculate. It's just the last value minus the first value, so 30 minus 1 gives us 29. Now, you can see from this set how the range is affected by outliers. This one person who has seen Star Wars 30 times is making our range absolutely huge, 29. If that person wasn't included in there, our range would be 16 minus 1 or 15. So it would basically be cut in half. Okay? So we don't usually use the range because of its sensitivity to outliers. Let's go ahead and figure out our Q1, Q2, and Q3, so our quartile boundaries here. We want to first, I think, figure out Q2, because that's our median. So let's look for the value that is going to divide this thing in half. So we've got 20 values. We are looking for, well, the bottom half is going to have 10. The top half is going to have 10 as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our Q2 boundary right there, the median of our data set. So as we've done before, we're going to take the average of those two values that fall on either side of it. So Q2 is going to be 5 plus 6 divided by 2, or 5.5. Our Q1 value is going to be the median of the lower half of our data set. So we've got 10 values in the lower half. We want something that is going to divide it 5 and 5. So 1, 2, 3, 4, 5. There is our Q1 boundary right there. Since we don't have a specific number there that divides them, we're going to average the two numbers on either side. But that's a 3 and a 3. So our Q1 boundary is just going to be 3. And our Q3 boundary, well, that's the median of the upper half. So again, we want 1, 2, 3, 4, 5. Here's our Q3 boundary. We have a 10 and a 10 on either side. So we are going to have our Q3 is going to be 10. Our interquartile range is the difference between Q3 and Q1. So IQR equals Q3 minus Q1. It's going to be 10 minus 3 is going to be 7. So this gives us a little bit better estimate of how spread out our data are. So those are quartiles. What are percentiles? Well, Percentiles are like quartiles, except rather than dividing them into your data set into 4 groups, you're dividing it into 100 groups. Okay, you're looking at what percentage of the data your value lies above. So similar to quartile, but divided into 100 groups rather than 4. A value in the 60th percentile is greater than 60% of the other values. So you're looking for the percentage of the data set that is less than the value that you're interested in. Okay? So to put it in other terms, Q1 is our 25th percentile because it is bigger than 25% or 1/4 of your data. Q2 is the 50th percentile. Q3 is the 75th percentile, because it is 75% of the data below it, 25% above it. So let's think about so referring back to our previous example about asking people how many times they'd seen Star Wars, let's find the 90th percentile, okay? Otherwise known as, sometimes abbreviated as P90 here. So what is the 90th percentile? Well, it's the value that divides the lower 90% from the top 10%. Okay, so it's that split between the 90 bottom and the top 10. So that value is going to be 90% of the 20 people surveyed. So we figure out what that is. That is 0.90 times 20 equals, punch this into our calculator, 18. So we have 18 people in our lower 90%, and we have 2 people in our upper 10%. So if we flip back to the previous slide, we just have to, the division is going to be right here. Okay? So below that green line here, we've got 90% of the data over here, and then we've got 10% that are above it. So what is the number that divides that 90% from that 10%? Well, it's halfway in between 15 and 16. So as we've done before, we're going to take the average of those two values on either side. So P90 is going to be 15 plus 16 divided by 2 is 15.5. Is our P90 value. So what can we sort of conclude from this number? We could say something like, therefore, only 10% of attendees, okay, people who had attended this conference, have seen Star Wars 16 or more times. Now, I have to round that 15.5 off because it doesn't make sense to talk about having seen it 15.5 times, but whether I round it up or down is going to depend on what I'm saying. If I'm saying that I'm interested in the people who have seen it more than that P90 value, I'm going to round it up to 16 and say 16 or more. If I was interested in saying how many, if I was interested in the lower 90%, I would say that 90% of the people had seen it 15 or fewer times. Okay? So you round up or down depending on the context. So let's say I have seen Star Wars 4 times. What percentile would that put me in? Well, let's go back and look at our data set here. We find where we would fit in here. We would fit in, well, 4 would go in right about here, or possibly here, or possibly here. Okay, we're not exactly sure where to put it. And because we have such a small data set, it kind of matters whether it goes in the beginning of that list of 4s or the end of that list of 4s. So let's just think about how many values are less than 4 here. We've got 1, 2, 3, 4, 5, 6 values out of 20 that are below me in this list, or lower than 4. So we could say, this is a reminder for all those who are attending the district, that there are 6 people below me, 6 people below 4. So 6 out of 20 people is 0.3, which suggests that this is the 30th percentile. We could also look at how many numbers are above 4 in this list. So just going back and counting, we would find that there are 12 numbers that are above 4 in that list. 12 out of 20 is 0.6. So suggests that there's 60% of the data above 4, or 40% below. So this would be the 40th percentile. So we've got sort of 2 conflicting numbers here. We're either in the 30th percentile, we're either in the 40th percentile. In a data set like this with a relatively small number of values, we can't usually be much more precise than that. So it's going to be somewhere in the 30th to 40th percentile. I mean, we could average them and say the 35th percentile, but that isn't much more accurate. Okay.